Hi students, let me welcome you all to my third video on the chapter electrochemistry. In the previous video, we discussed electrode potential concept, standard electrode potential concept, measurement of electrode potential, is it not? Measurement of standard electrode potential by using standard hydrogen electrode as reference electrode. At the same time, we discussed significance of electrochemical series. Now in today's video, we'll go to the next discussion, that is Nonstick equation for electrode potential. And of course, we are going to study Nonstick equation for determining electrode potential as well as cell potential in this particular video, right? As you know that standard electrode potentials can be determined by using standard hydrogen electrode as reference electrode. And of course, these are the electrode potentials at 1 molar concentration and yes, it is 298 kelvins temperature. Every electrode is characterized by standard electrode potential. There is a potential developed when metal is placed in 1 molar solution of its electrolyte at 298 kelvins under a pressure of 1 bar in the case of gaseous electrodes. That is, standard electrode potential is a electrode potential of electrode system for a fixed temperature and fixed concentration. But here, I want to determine electrode potential of electrode system at any temperature and concentration. I want to determine electrode potential of electrode system at any temperature and concentration at any pressure. For that purpose, I can make use of this Nonstick equation. That is the next discussion, Nonstick equation for electrode potential. And of course, for the reaction of the type, if I say this is the reduction reaction, that is reduction of metal ion. Yes, it is reduction of metal ion into, yes, it is metal. For this particular reduction reaction, I am going to write a Nonstick equation for electrode potential. That is electrode potential EM is equal to, yes, it is E naught M. E naught M is standard electrode potential of given metal electrode, yes, minus RT by NF ln, yes, it is into, yes, it is molar concentration of, yes, it is products of this particular reaction divided by molar concentration of reactants of the above reaction. Yes, look at this. This is general expression for, yes, it is electrode potential, that is Nonstick equation for this particular reduction reaction. And therefore, I can rewrite this equation as, that is E naught M minus, right, RT divided by NF. Ln can be replaced by log to the base E. Ln can be replaced by log to the base E. Here in this particular reaction, molar concentration of products, and this is molar concentration of a solid metal divided by molar concentration of metal ion. That is Mn plus ion. This is what we call it as, yes, it is expression for the electrode potential, right? Look at this, this is expression for electrode potential. And of course, as you know that as far as this particular Nonstick equation is concerned, this is electrode potential, EM is a electrode potential, E naught M is a standard electrode potential, that is from electrochemical series. Every electrode system is characterized by standard electrode potential, that is E naught M. R is a gas constant, you know that R is equal to 8.314 joules per Kelvin per mole. This is value of gas constant R there. T is a temperature in kelvins. T is a temperature in kelvins. This is T there. F is a Faraday's constant, that's equal to 96,000. Yes, it is 487 coulombs. 96,487 coulombs, or it is approximated as 96,500 coulombs. This is Faraday's constant F there, and of course here it is M is a molar concentration of, yes, it is metal in solid state, that will be taken as 1. You know that during chemical reaction, molar concentration of solids or liquids remain constant. Therefore, active mass of solids and pure solids and pure liquids will be taken as 1. Therefore, molar concentration of solid metal is 1. And of course, here we have, yes, it is molar concentration of metal ion. It is Mn plus N is a molar concentration of metal ion. Concentration of metal ion is present in electrolytic solution. Okay, now. And of course, as far as N is concerned, this is, look at this, N is a charge of the metal ion. In this particular electrode reaction, N is a charge of the metal ion, or you can say number of electrons gained by 1 mole of metal ion. That is what we call it as N there. Yes, for this particular Nonstick equation for electrode potential. Now at this moment, as far as now this particular equation becomes, right, Em is equal to, yes, it is E naught of M. Em is equal to E naught of M minus, look at this, RT by NF. This is RT by NF log to the base E. ನಾನು ಏನು ಮಾಡ್ತೀನಿ ಈಗ ಅಂದ್ರೆ log to the base E ಅನ್ನ log to the base 10 ಕನ್ವರ್ಟ್ ಮಾಡ್ತೀನಿ. log to the base E ಅನ್ನ log to the base 10 ಮಾಡಿದ್ರೆ you have to multiply it by 2.303. That is 2.303. Yes, RT by, yes, it is NF. Log to the base 10 of, right? Your molar concentration of solid metal is taken as 1, right? And of course divided by molar concentration of metal ion. Yes, it is molar concentration of metal ion. Log to the base 10 of 1 by, yes, it is molar concentration of metal ion ideyalla. That is log to the base 10 of, yes, it is 1 by molar concentration of metal ion is equal to minus of log to the base 10 of molar concentration of metal ion. Hige ಬರಿಬೋದಲ್ಲ? Yes. Log to the base 10 of 1 by molar concentration of metal ion is equal to minus log to the base 10 of molar concentration of metal ಅಂತ ಬರಿಬೋದು. ಹಾಗಾಗಿ equation becomes E of Em is equal to, yes, it is E naught of M. Log to the base 10 of 1 by molar concentration of metal ion is replaced by minus log to the base 10 of molar concentration of metal ion ಏನಾಗುತ್ತೆ? Minus into minus plus ಆಗುತ್ತೆ. 2.303. Yes, it is RT by NF. Log to the base 10 of, yes, it is molar concentration of metal ion. Log to the base 10 of molar concentration of metal ion. This is what we call it as Nonstick equation. Yes, this is what we call it as Nonstick equation for electrode system. Nonstick equation for calculating, yes, it is electrode potential at any temperature and concentration of metal ion. On the basis of this Nonstick equation, I can take some decisions. As the temperature increases, electrode potential increases. As the molar concentration of metal ion increases, electrode potential also increases. I already discussed it, while discussing factors affecting on electrode potential. As the concentration of metal ion increases, electrode potential increases. As temperature increases, electrode potential increases. This is what we call it as Nonstick equation. Okay? Now at this moment, you'll see here, if I say this is calculation of electrode potential at any temperature and concentration of metal ion. If I fix the temperature as 298 kelvins, right? If the temperature is equal to 298 kelvins, the equation only T is equal to 298 kelvins substitute mani, then equation takes the form Em is equal to, yes, it is E naught M plus 2.303 into 8.314 into, yes, it is 298 divided by N into 96,500 coulombs. 2.303 R value substitute ಮಾಡಿದ್ರಿ 8.314 ಅಂತ ಹೇಳಿ temperature ನಾನು 298 kelvins ತಗೊಂಡಿದ್ದೀನಿ. Yes, F we know that 96,500 coulombs, right? Then log to the base 10 of, yes, it is molar concentration of metal ions. Log to the base 10 of molar concentration of metal ions. We'll simplify ಮಾಡಿದ್ರೆ, look at this. Equation takes the form Em is equal to, yes, it is E naught of M plus 2.303 8.314 into 298 divided by 96,500 coulombs ಎಷ್ಟಾಗುತ್ತೆ ಅಂದ್ರೆ it will be 0.059 divided by N ಆಗುತ್ತೆ. ನೋಡಿ, ನ್ಯೂಮರೇಟರ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ ಡಿನಾಮಿನೇಟರ್ ಇಂದ ಡಿವೈಡ್ ಮಾಡಿ ಆಗ ನಿಮಗೆ 0.059 by, yes, it is N ಬರ್ತದೆ. That is log to the base 10 of, yes, it is molar concentration of metal ion. Yes, so this is what we call it as one more, yes, it is form of Nonstick equation. This particular Nonstick equation is applicable. This particular Nonstick equation is applicable only at 298 kelvins. And this is at any temperature and concentration of metal ion. ಹೌದಾ? ಬಟ್ ಇದು ಈ ಈಕ್ವೇಶನ್ ನೀವು ಬಳಸಬೇಕಾದ್ರೆ ಟೆಂಪರೇಚರ್ ಎಷ್ಟಾಗಿರಬೇಕು 298 ಕೆಲ್ವಿನ್ಸ್ ಆಗಿರಬೇಕು. Yes, so this is what we call it as Nonstick equation for electrode potential. Yes, Nonstick equation for electrode potential. Now I am going to write this Nonstick equation for different electrode systems here. Okay, now I am going to write Nonstick equation for different electrode systems. Say for example, for copper electrode system, copper bar, yes it is copper 2 plus. For copper electrode system, I write Nonstick equation as E of copper is equal to, yes it is E naught of copper plus 0.059 divided by N, yes it is log to the base of molar concentration of copper ions. This is Nonstick equation for, yes it is copper electrode, where N is equal to 2 here. Hagagi N is equal to 2 anta hakbeku. This is Nonstick equation for copper electrode. Hagene I can write Nonstick equation for zinc electrode also. That is E naught of zinc plus 0.059 divided by 2. Howda? This is Nonstick equation for zinc, and of course E naught of zinc is equal to E of zinc is equal to E naught of zinc plus 0.059 by 2 log to the base 10 of, yes it is molar concentration of Zn plus 2. This is Nonstick equation for, yes it is zinc electrode. Howda? I can write Nonstick equation for hydrogen electrode. That is E of S2 is equal to, yes, E naught of S2, right? E naught of S2 plus 0.059 divided by 1, because for hydrogen electrode it will be, yes it is half S2 bar H plus. For hydrogen electrode, hydrogen is in touch with H plus ions. Charge of H plus S2 1 ಆಗಿರೋದ್ರಿಂದ N is equal to 1 ಹಾಕ್ತೀನಿ, and log to the base of, yes it is molar concentration of better ions. ಹೌದಾ? ಈ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಈಕ್ವೇಶನ್ ಇಂದ ನಾನೊಂದು ಡಿಸಿಷನ್ ತಗೋಬಹುದು. ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ ನೋಡಿ, that is electrode potential of hydrogen electrode is equal to E naught of S2 is 0.0. You know that standard electrode potential of hydrogen electrode is 0.0, and of course plus 0.059. ಹೌದಾ? Log to the base of H plus can be replaced by minus pH. ಗೊತ್ತಲ್ಲ ನಿಮಗೆ, pH is equal to minus log to the base of H plus ಅಲ್ವಾ? ಹಾಗಾಗಿ log to the base of H plus can be replaced by minus pH. ಹಾಗಾಗಿ ಏನಾಯ್ತು, that is E of S2 is equal to minus 0.059 into pH. That is, if you know the pH of the HCl solution in hydrogen electrode, if you know the pH of HCl solution in hydrogen electrode, you can determine its, yes it is electrode potential there. Howda? You can determine electrode potential. This is the equation that I can draw on the basis of this particular Nonstick equation. Okay, now these are the, that is expression for Nonstick equation for different types of electrodes. Okay, now so this is what we call it as Nonstick equation for, yes it is electrode potentials. Nonstick equation for electrode potentials. ಇದನ್ನ ಸ್ವಲ್ಪ ನೀವು ಕರೆಕ್ಟ್ ಆಗಿ ನೆನಪಿಟ್ಕೊಂಡ್ರೆ ಸಾಕು. Em is equal to E naught of M plus 2.303 RT by NF log to the base of molar concentration of metal ion. Temperature 298 kelvins ಆದರೆ Nonstick equation takes this form. That is Em is equal to E naught of M plus 0.059 divided by N log to the base of molar concentration of metal ion. So this is what we call it as Nonstick equation. Yes. Now at this moment I am going to, yes it is introduce one more equation, that is Nonstick equation for cell potential. Electrode potential is a property of electrode, whereas cell potential is a property of, yes it is galvanic cell. You know that galvanic cell can be constructed by connecting two electrode systems, externally by electric wire, internally by salt bridge. Now let us see Nonstick equation for cell potential now. Yes. Now let us see Nonstick equation for cell potential. You know, for a given galvanic cell, yes, E of cell is equal to, yes, E of cathode minus E of anode. You know this. The potential difference between two electrode systems, so that is what we call it as cell potential. Again, standard cell potential E naught of cell is equal to E naught of cathode minus E naught of anode. You know these formulas, right? Howdalva? And I am going to, yes it is obtained Nonstick equation for cell potential by taking Daniell cell as an example. You know, for the Daniell cell, the cell reaction is Zn plus CO2 plus in aqueous solutions. Okay, that gives, that is Zn2 plus ions in aqueous solutions, and of course copper, that is in solid. This is cell reaction for the, yes, it is Daniell cell. Here zinc undergoes oxidation, copper ions undergo reduction. At the same time here, when zinc oxidizes, zinc is going to lose 2 electrons. Number of electrons lost by 1 mole of number of electrons lost by 1 atom of zinc is 2. Number of electrons gained by 1 ion of copper ions, copper plus 2 will be 2. That's why that is number of electrons exchanged between, yes, it is anode and cathode. Number of electrons exchanged between anode and cathode in the Daniell cell is 2, and that is what we call it as N is equal to 2 here. And of course, if you want to calculate, yes, it is E of cell, E of cell is equal to, yes, it is in the case of Daniell cell, E of copper minus, yes, it is E of, yes, it is anode, that is what we call zinc. E of cell is equal to E of cathode minus E of anode ಆಗಿರೋದ್ರಿಂದ, for Daniell cell, E of cell is equal to, in the Daniell cell, copper is cathode, zinc is anode, ಹಾಗಾಗಿ E of copper minus E of zinc ಆಗುತ್ತೆ. And I can write the expression for E of copper on the basis of Nonstick equation, that is E of copper is equal to, yes, E naught of copper plus RT by NF andre 2F, because in the case of copper electrode, the charge of the copper ion 2 irodrinda, yes, it is RT by 2F, and of course log to the base E of concentration of copper ions. This is what we call it as the expression for electrode potential E of copper. E of copper is replaced by E naught of copper plus RT by 2F log to the base E of concentration of copper ions. ಇದು ಏನಾಯ್ತು ಈಗ ಕ್ಯಾಥೋಡ್ ಆಗಿದೆ, ಇದು ಕ್ಯಾಥೋಡ್, ಇದು ಮೈನಸ್ ಆನೋಡ್. ನೋಡಿ ಆನೋಡ್ ಇಸ್ ಜಿಂಕ್ ಆಗಿರೋದ್ರಿಂದ ಮೈನಸ್ ಏನಾಗುತ್ತೆ, ದಟ್ ಈಸ್ E naught of zinc plus yes, it is RT by 2F. once again here RT by 2F, ಯಾಕಂದ್ರೆ number of electrons lost by 1 atom of zinc is 2, or you can say charge of zinc ion is 2, and of course log to the base E of, yes, it is concentration of Zn plus 2 ions. So this is what we call it as anode here, cathode minus anode ಆಯ್ತು. ಹೌದಾ? ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ ಈಗ. This is equal to, look at this, E naught of copper minus, yes, it is E naught of, yes, it is zinc ಅಂತ ಬರ್ಕೋಬಹುದು. ಇದು ಒಂದು ಪಾರ್ಟ್ ಆಗುತ್ತೆ. E naught of copper minus E naught of zinc ಆಗುತ್ತೆ. ಹೌದಾ? ಈಗ ನೋಡಿ ಇಲ್ಲಿ ಮೈನಸ್ ಅಂತ ಹಾಗೆ ಇಟ್ಕೊಳ್ಳಿ, ಇದು ಮೈನಸ್ ಅಂತ ಹಾಗೆ ಇಟ್ಕೊಂಡ್ರೆ ಎಸ್ ಹಾಗೇನಾಗುತ್ತೆ ನೋಡಿ, RT by, yes, it is 2F ಕಾಮನ್ ಇದೆ. ಹೌದಾ? RT by 2F ಇಲ್ಲೂ ಕಾಮನ್ ಇದೆ, ಇಲ್ಲೂ ಕಾಮನ್ ಇದೆ, ಹಾಗಾಗಿ and that is equal to, yes, ನೋಡಿ RT by 2F ಕಾಮನ್ ತಗೊಂಡ್ರೆ that is log to the base E of, yes, it is concentration of Zn plus 2 ions, ಹೌದಾ, minus log to the base E of, yes, it is concentration of, yes, it is copper ions. So this is the expression that I can get. ನೋಡಿ ಇಲ್ಲಿ minus RT by 2F ಅನ್ನು ಕಾಮನ್ ತಗೊಂಡ್ರೆ ಉಳಿಯೋದೇನು, log to the base E of Zn plus 2 minus ಇಲ್ಲಿ ಪ್ಲಸ್ ಇದೆ, ಮೈನಸ್ ಇಂಟು ಮೈನಸ್ ಪ್ಲಸ್ ಆಗುತ್ತಲ್ಲ, ಪ್ಲಸ್ RT by 2F ಕಾಮನ್ ಅಂದ್ರೆ log to the base E of, yes, it is concentration of copper ions. Now at this moment E naught of copper minus E naught of zinc can be replaced by, yes, it is E naught of cell. ಹೌದಾ? E naught of copper minus E naught of zinc is replaced by E naught of cell minus, yes, it is RT by 2F for Daniell cell, yes, and of course this is equal to log to the base E of log A minus log B andrenu, log A by log B, that's equal to, yes, it is log A andrenu, that is concentration of zinc ions divided by concentration of, yes, it is concentration of, yes, it is copper ions. Log A minus log B andre Zn plus 2 divided by copper plus 2 concentration. So this is what we call it as the expression for E of cell. Expression for E of cell. ಹೌದಾ? ನೀವೇನಾದ್ರೂ ಇದನ್ನ log to the base ಅನ್ನ log to the base 10 ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? That is E of cell is equal to, yes, it is E naught of cell minus 2.303 RT by 2F, yes, log to the base E of, yes, it is concentration of Zn plus 2 ions divided by concentration of, yes, it is copper ions. So this is concentration of copper ions. So this is what we call it as the expression for cell potential for Daniell cell. This is what we call expression for the cell potential in the case of Daniell cell. ಹೌದಾ? ಇಲ್ಲಿ ಗಮನಿಸಬೇಕು. That is log to the base C ಇದೆಲ್ಲ ಇದು ಏನಾಗುತ್ತೆ ಈಗ log to the base 10 ಆಗುತ್ತೆ. Yes, log to the base ಇದು ಏನಾಗುತ್ತೆ log to the base 10 ಆಗುತ್ತೆ, ರೈಟ್? ಯಾಕಂದ್ರೆ 2.303 RT by 2F gain multiply ಮಾಡಿದೀನಿ, 2.303 multiply ಮಾಡಿದೀನಿ, ಆಗ log to the base C becomes log to the base 10 ಆಯ್ತು. ಓಕೆನಾ? ಇಲ್ಲಿ ಗಮನಿಸಿ, log to the base of Zn plus 2 by copper plus 2 ಇದೆಯಲ್ಲ, Zn plus 2 is a concentration of metal ion in the cell reaction at the product side. ಹೌದಾ? Copper plus 2 is a concentration of metal ion of the galvanic cell in the reactant side. ಹೌದಾ? ಹಾಗಾಗಿ this expression can also be written as, yes, it is E of cell, yes, it is equal to E naught of cell minus 2.303 RT by 2.303, yes, it is RT by, yes, it is 2F, yes, it is log to the base 10 of, right? Zn plus 2 ಬದಲಾಗಿ ಏನು ಮಾಡ್ತೀನಿ ನಾನು, I am going to write, yes, it is molar concentration of products ಅಂತ ಬರ್ತೀನಿ, because Zn plus 2 on the product side ಇರೋದ್ರಿಂದ, divided by copper plus 2 ions ಬದಲಾಗಿ ಏನು ಮಾಡ್ತೀನಿ, that is molar concentration of reactants in the cell reaction ಅಂತ ಬರೀಬಹುದು. Yes, ಇಲ್ಲಿ 2 for Daniell cell, for a galvanic cell 2 can be replaced by N. ಹೌದಾ? For a galvanic cell, N is the number of electrons exchanged between, yes, it is cathode and anode. Okay, now this is what we call Nonstick equation for, yes, it is a galvanic cell where N number of electrons will be exchanged between cathode and anode, and of course E of cell is a cell potential, E naught of cell is a standard cell potential, R is a gas constant, T is a temperature, F is a Faraday's constant, and of course this is molar concentration of products divided by molar concentration of reactants. ಹೌದಾ? ಈಗ ಬರ್ತೀನಿ. For a cell reaction of this type, on the cell reaction ತಗೋತೀನಿ, yes, for the cell reaction of this type, yes, that is if I consider that is Mn, right, solid, right, that becomes, yes, it is M2 N plus in aqueous solution, and that gives M1 N plus in aqueous solutions. ಹೌದಾ? Plus that is M2 in solid state. ಇದು ಒಂದು cell reaction ಅಂತ ಇಟ್ಕೊಳ್ಳಿ, ಜನರಲ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಬರೀತಾ ಇದ್ದೀನಿ. ಓಕೆನಾ? ಈಗ ನೋಡಿ, E of cell is equal to, yes, E naught of cell minus 2.303, yes, RT by, yes, it is NF. ಹೌದಾ? 2.303 RT by NF log to the base 10 of molar concentration of products. ಈ cell reaction ಅಲ್ಲಿ ಎರಡು products ತಾನೆ, that is molar concentration of M1 plus N into molar concentration of M2 ಆಯ್ತು, divided by reactants ಯಾವುದು, molar concentration of, yes, it is M1 into molar concentration of M2 plus N ಆಯ್ತು. This is the expression for cell potential for this reaction. But you know, M2 is a solid, M1 is a solid, ಹಾಗಾಗಿ ಏನಾಯ್ತು, molar concentration of solid metals M1 is equal to solid metal M2, that's equal to 1 ಅಲ್ವಾ, ಹಾಗಾಗಿ M2 M1 cancel ಆಗುತ್ತೆ. Yes, and you left with, you know, the molar concentration of metal ion that is at anode divided by molar concentration of metal ion at cathode ಆಗುತ್ತೆ. Yes, ನೋಡಿ ಇದರ ಬೇಸಿಸ್ ಮೇಲೆ ಹೀಗೆ ಹೇಳ್ಬೋದಲ್ಲ, yes, it is as the molar concentration of metal ion at, yes, it is anode M1 plus ಏನು molar concentration of metal ion at anode, because M1 is undergoing oxidation. As the molar concentration of metal ion at anode increases, cell potential decreases. ಹೌದಲ್ವಾ? M1 plus N ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಆದ್ರೆ ಏನಾಗುತ್ತೆ, E of cell ವ್ಯಾಲ್ಯೂ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಹಾಗೇನೆ as the molar concentration of metal ion at cathode increases, cell potential increases. So ಇದ್ರ ಬೇಸಿಸ್ ಮೇಲೆ ಆ ಡಿಸಿಷನ್ಸ್ ಅನ್ನ ತಗೋಬಹುದು. So this is what we call it as expression for cell potential. And of course at 298 kelvins ಏನಾಗುತ್ತೆ, E of cell is equal to, yes, it is E naught of cell minus 0.0591, and of course 59 into N log to the base 10 of, yes, M1 plus N. ಹೌದಾ? M1 plus N, and of course divided by, yes, it is M2 plus N. This is what we call it as the expression for cell potential at 298 kelvins. See, this is at 298 kelvins. ಹೌದಾ? ಓಕೆನಾ? ಇನ್ನು ಈ ರೀತಿ cell reaction ಇರ್ತದೆ ಕೆಲವು ಸಾರಿ. ನೋಡಿ, I am going to write one more alternate expression for the cell potential. ಇನ್ನೊಂದು expression ಬರೀತೀನಿ cell potential ಗೆ. Look here, that is For the reaction of the types A times A plus B times B gives, yes, it is C times C plus D times D. This is one cell reaction of control. Let me write the expression for cell potential. E of cell is equal to, yes, E naught of cell minus, yes, it is RT by NF. RT by NF. N is the number of electrons exchanged between anode and cathode. Yes, log to the base E of RT irodrinda log to the base E baritini. Molar concentration of products agirodrinda C and D are the products of the divided by molar concentration of reactants. A and B are the reactants. Illi C and D products agirodrinda product of molar concentration of products divided by product of molar concentration of reactants. Illi nodi coefficient of reactants and products enide A, B, C, D ide. But illi coefficients of reactants and products 1, 1 ittu. Illi A, B, C irodrinda, that is, as you know, last year first PUC equilibrium discuss ಮಾಡಿದ್ರಲ್ಲ ನೀವು, ಹಾಗೆ equilibrium chapter discuss ಮಾಡಿದ್ರು ಆ ತರ molar concentration of C to the power C, molar concentration of D to the power D, molar concentration of A to the power A, molar concentration of B to the power B. This is what we call it as the expression for cell potential for this particular cell reaction. Expression for cell potential for this particular cell reaction. If I say the reaction of this type, look here, that is nickel, yes, it is solid, that reacts with Ag plus ions, right? Ag plus ions, right? That leads to what we call it as Ni2 plus ion in aqueous solutions, right? Plus 2Ag, that is in solid state ಅಂತ ಇಟ್ಕೊಳ್ಳಿ, ಹೌದಾ? ಈ ಒಂದು cell reaction ಗೆ if I ask you to write the expression for cell potential ಅಂದ್ರೆ ನೋಡಿ ಏನಾಗುತ್ತೆ? E of cell is equal to, yes, it is E naught of cell minus ಇಲ್ಲಿ RT ಬದಲಾಗಿ ಏನು ಮಾಡ್ತೀನಿ ಈಗ 2.303 RT by, yes, it is NF ಅಂತ ತಗೊಂಡು log to the base ಏನಾಗುತ್ತೆ ಈಗ log to the base becomes log to the base 10 ಆಗುತ್ತೆ. ಇಲ್ಲಿ ನೋಡಿ C and D, these are the C and D, ಹೌದಾ? ಏನಾಗುತ್ತೆ products ಏನಾಗುತ್ತೆ concentration of, yes, it is Ni plus 2, ಹೌದಾ? concentration of Ag to the power 2 ಆಗುತ್ತೆ. These are the products, ಹೌದಾ? divided by reactants ಏನು, yes, it is concentration of nickel, yes, into concentration of Ag plus, ಹೌದಾ? concentration of nickel to the power 1, ಇಲ್ಲಿ 1 ಇದೆ. concentration of Ag plus to the power 2, actually coefficient of Ag plus ಎಷ್ಟಿದೆ 2 ಇದೆ. ಈಗ ನೋಡಿ, that is molar concentration of solid nickel is equal to molar concentration of silver, solid silver, that's equal to 1 ಆಗಿರೋದ್ರಿಂದ Ag Ni cancel ಆಗುತ್ತೆ. You will act with this, ಹೌದಾ? Then and of course E of cell is equal to, yes, E naught of cell minus 2.303 RT by 2F ಆಗುತ್ತೆ ಈಗ. ಹೇಗೆ ಹೇಳಿ? N is equal to 2 because one atom of nickel loses 2 electrons. 2 Ag plus ions will gain 2 electrons. ಹಾಗಾಗಿ number of electrons lost will be equal to number of electrons gained ಆಗಿರೋದ್ರಿಂದ N is equal to 2 ಆಗುತ್ತೆ. Log to the base 10 of, yes, ಉಳಿಯೋದೇನು concentration of, yes, it is Ni plus 2 divided by, yes, it is concentration of Ag plus to the power 2. This is what we call it as expression for the cell potential for this particular cell reaction. ಅದೇ ನೀವು temperature 298 ಹಾಕಿದ್ರೆ ಆಗ ಈ ವ್ಯಾಲ್ಯೂ ಏನಾಗುತ್ತೆ 0.0591 by 2 ಆಗುತ್ತೆ. 0.059 divided by 2 ಆಗ್ಬಿಡುತ್ತೆ. Yes, so this is what we call it as expression for cell potential. Okay na? Now at this moment, let me take up the relationship between E naught of cell and equilibrium constant. Let me have the relationship between standard cell potential and of course equilibrium constant. That is relationship between standard cell potential and equilibrium constant. Yes. Consider a reaction of the type A times A plus B times B gives, yes, it is C times C plus D times D. This is one cell reaction. Yes. And remember, yes, it is as far as expression for the cell potential is concerned, that is equal to E naught of cell minus 2.303 RT by, yes, it is NF log to the base 10 of products, concentration of C into concentration of D and C to the power of C, D to the power of D is divided by reactants. Concentration of A into concentration of B, and each concentration term raised to the power equal to stoichiometric coefficients. Just imagine, as the chemical reaction proceeds, concentration of C and D increases and that of A and B decreases. Reaction ನಡೆದಂಗೆಲ್ಲ ಏನಾಗುತ್ತೆ, concentration of C and D ಜಾಸ್ತಿ ಆಗುತ್ತೆ, A and B ಕಡಿಮೆ ಆಗುತ್ತೆ. ಹಾಗಾಗಿ ಏನಾಗುತ್ತೆ, the value of this particular expression increases. C and D ಜಾಸ್ತಿ ಆಗಿಬಿಟ್ಟು A and B decrease ಆದರೆ ಈ value complete ಜಾಸ್ತಿ ಆಗುತ್ತೆ. That means the value of this particular expression will be increased. As the reaction proceeds, value of this particular expression increases. If the value of this particular expression increases, ಏನಾಗುತ್ತೆ, E of cell, yes, it is decreases. ಹೌದಲ್ವಾ? ನೋಡಿ, ಈ ವ್ಯಾಲ್ಯೂ ಜಾಸ್ತಿ ಆದ್ರೆ E naught of minus this ಏನಾಗುತ್ತೆ, E of cell ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಹಾಗಾಗಿ at equilibrium, yes, at equilibrium, that chemical reaction will achieve highest concentration of products and lowest concentration of reactants. ಹಾಗಾಗಿ E of cell becomes equal to 0 at equilibrium. ಹಾಗಾಗಿ ಏನಾಗುತ್ತೆ ನೋಡಿ, E of cell ಬದಲಾಗಿ 0 ಹಾಕಿ, that's equal to E naught of cell minus, and of course 2.303 RT by, yes, it is NF, log to the base 10 of, nodi, at equilibrium, this particular expression, concentration of C to the power of C into concentration of D to the power of D, concentration of A to the power of A into concentration of B to the power of B. ಈ expression ಏನಾಗುತ್ತೆ, that is equal to equilibrium constant Kc ಆಗುತ್ತೆ. ಹಾಗಾಗಿ because at equilibrium, yes, ಏನಾಗುತ್ತೆ, concentration of C into concentration of D, yes, divided by concentration of A, and of course concentration of B, that's equal to what, Kc. ಹೌದಾ? ಹಾಗಾಗಿ equation takes the form, yes, it is E naught of cell is equal to 2.303 RT by NF log to the base 10 of, yes, it is Kc. So this is what we call it as relationship between E naught of cell and, yes, it is Kc equilibrium constant. Yes, ಇದನ್ನ ಸ್ವಲ್ಪ ಗಮನದಲ್ಲಿ ಇಟ್ಕೊಳ್ಳಿ, because you can expect problems on this particular equation in your annual examination. And of course, if the temperature is 298 kelvins, ಏನಾಗುತ್ತೆ, this particular expression ಆಗುತ್ತೆ ನೋಡಿ, that is at 298 kelvins ಏನಾಗುತ್ತೆ ನೋಡಿ, that is E naught of cell is equal to 0.059 divided by n log to the base 10 of Kc ಆಗಿಬಿಡುತ್ತೆ. Yes, this is expression for, yes, it is the relationship between E naught of cell and equilibrium constant Kc at a temperature of 298 kelvins. At a temperature of 298 kelvins, 2.303 into R into T, T ಅಂದ್ರೆ 298 divided by 96,500 coulombs. ಈ ವ್ಯಾಲ್ಯೂ ಏನಾಗುತ್ತೆ, 0.059 ಆಗುತ್ತೆ. And of course this is the equation, relationship between E naught of cell and equilibrium constant. And as far as Daniell cell is concerned, ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಅನ್ನ ನೀವು Daniell cell ಗೆ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ, ಇದೇ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಅನ್ನ ನೀವು Daniell cell ಗೆ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ ನೋಡಿ, that is for Daniell cell, right? For Daniell cell ಏನಾಗುತ್ತೆ ನೋಡಿ, for Daniell cell ನಿಮಗೆ ಗೊತ್ತಿದೆ E naught of cell is equal to what, 1.10, that's equal to 0.059, that is at 298 kelvins I'm applying. Yes, it is divided by 2, because in the case of Daniell cell, number of electrons exchanged between cathode and anode will be 2 there. Yes, it is log to the base 10 of Kc ಆಗುತ್ತೆ. And of course, therefore, log to the base 10 of Kc is equal to 2 into 1.10 divided by 0.059. Cross multiply ಮಾಡಿದೀನಿ, that's equal to, yes, it is, it will be right. ನೋಡಿ ಏನಾಗುತ್ತೆ, 2 into, yes, 2 into 1.10 divided by 0.059, it comes out to be 37.288. Yes, it is 1. This is what we call it as, that is the, yes, it is the value here. Yes, and therefore ಏನಾಗುತ್ತೆ ನೋಡಿ, ಈಗ I want Kc there, that's equal to antilog of 37.2881. ಹೌದಾ? Or you can say this is antilog of 37 plus 0.2881 ಅಂತ ಬರೀಬಹುದಾ? Antilog of 37 is 10 to the power of 37, yes, into, yes, it is antilog of, yes, it is 0.2881 ಆಗುತ್ತೆ. Yes, antilog of A plus B is equal to antilog of A into antilog of B. ಹಾಗಾಗಿ ಈ ತರ ಬರೆದಿದ್ದೀನಿ. Yes, and of course antilog of 0.2881 ಇದೆಯಲ್ಲ, is approximately equal to 2, that is 10 to the power of 37. So this is expression for the equilibrium constant. Yes, in the case of linear cell, expression for the equilibrium constant in the case of linear cell 10 to the power of 37 ಇದೆ. antilog of 0.281 ಇದೆಯಲ್ಲ, ಅದು approximate 2 ಬರುತ್ತೆ. ಯಾಕೆಂದ್ರೆ ನಿಮಗೆ ಗೊತ್ತಿದೆ log to the base of 2 ಎಷ್ಟು 0.3010 ಹೌದಲ್ವಾ? log to the base of 2 ಎಷ್ಟು 0.3010. ಹಾಗಾಗಿ antilog of 0.3010 ಎಷ್ಟಾಗುತ್ತೆ? That's equal to 2. log to the base of 2 ಎಷ್ಟು 0.3010. Therefore antilog of 0.3010 ಎಷ್ಟು 2 ಆಗುತ್ತೆ. ಇದೆಷ್ಟಿದೆ? antilog of 0.2881 ಇದೆಯಲ್ಲ, approximately equal to 0.3 ಅಲ್ವಾ? ಹಾಗಾಗಿ this is antilog of 0.2881 ಇದೆಯಲ್ಲ, that is taken as 2 here ಅಷ್ಟೇನೆ. Yes, so this is what we call it as expression for the equilibrium constant for the Daniell cell. Okay na, at 298 kelvins, right? Now at this moment, let me have a relationship between, yes, let me have a relationship between E naught of cell and the standard free energy change. Yes, that is one more discussion we have, right? Relationship between, yes, E naught of cell and standard free energy change, that is delta G naught. Let me go to the free energy refers to the amount of energy available for doing useful work at constant temperature and pressure. Amount of energy available for doing useful work at constant temperature and pressure, that is what we call it as free energy there. And delta G naught is standard free energy change. Of course, as far as galvanic cells are concerned, you know, galvanic cells involve conversion of chemical energy into electrical energy. That means certain amount of work will be done during the cell reaction. Certain amount of work will be done during the cell reaction. Hagagi, what I said that amount of work done in the Daniell cell, amount of work done in the Daniell cell is equal to quantity of electricity produced is given by NF. NF is a quantity of electricity produced, and of course into, yes, it is that is standard cell potential, that is potential difference between two electrode systems under standard conditions. That is amount of work done in any galvanic cell is given by quantity of electricity produced into, yes, it is the potential difference, that is E naught of cell. And of course whenever useful work is done, ಏನಾಗುತ್ತೆ? Free energy decreases. ನಾನು ಹೇಳಿದ್ದಲ್ಲ, energy available for doing useful work is called free energy. Whenever useful work is done, free energy decreases, means delta G naught becomes negative. Yes, delta G naught becomes negative. ಹಾಗಾಗಿ the amount of work done can be replaced by, yes, it is minus delta G naught. ಯಾಕಂದ್ರೆ whenever useful work is done, free energy decreases ಅಥವಾ standard free energy change becomes negative. ಹಾಗಾಗಿ amount of work done is equal to delta G naught minus delta G naught. Therefore delta G naught is equal to minus NF into, yes, it is E naught of cell. This is what we call it as the relationship between, yes, it is the standard free energy change and standard cell potential. And of course this is Faraday's constant. This is number of electrons exchanged between cathode and anode in a given galvanic cell. This is what we call it as relationship between E naught of cell and delta G naught. Now at this moment I can have one more relationship, that is relationship between, yes, relationship between delta G naught and, yes, it is Kc. ಇದು ಕೂಡ ಆಗಬಹುದು. Relationship between delta G naught and Kc. ಇಲ್ಲೇ ಇದೆ ನೋಡಿ, that is delta G naught is equal to minus NF ಅಲ್ವಾ? E naught ಬದಲಾಗಿ ನಾನು ಏನು ಮಾಡ್ತೀನಿ? 2.303 RT by NF, yes, log to the base 10 of, yes, it is Kc. ನಿಮಗೆ ಈ expression ಗೊತ್ತಿದೆ. Yes, just now we discussed Kc can be, E naught of cell can be replaced by 2.303 RT by NF log to the base of Kc. NF cancel ಆಗುತ್ತೆ. Then you left with delta G naught is equal to minus 2.303 RT log to the base 10 of, yes, it is Kc. This is what we call it as the relationship between delta G naught and Kc. And of course you already studied this particular equation in first PUC under thermodynamics. ಹೌದಾ? ಇದನ್ನು ನೀವು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ರೆ once again I can use this particular expression even in electrochemistry under galvanic cells. Agboodala? So this is what we call it as the relationship between E naught of cell and delta G naught, and of course relationship between delta G naught and Kc there. Now this moment we'll go to the numerical problems on, yes, it is Nonstick equation. Agboodala? We'll see that. Yes. Now let us see first problem on Nonstick equation, numericals on Nonstick equation, right? Represent the cell in which the following reaction takes place. Cell reaction is given where magnesium is oxidized, silver ions will be reduced. Calculate its E of cell if E naught of cell is equal to 3.17 volts. First, E cell reaction anna yen madbeku, that is cell representation madbeku. You have to write the cell representation for this particular cell reaction. Nimage gottide cell representation madbekare yen madbeku, that is reactant at anode separated by, yes, it is product at anode, yes, double vertical line, reactant at cathode, and of course product at cathode. This is the cell representation. Illi reactant at anode, Mg undergoes oxidation. Now the Mg is oxidized to Mg plus 2. 0 becomes plus 2. Oxidation number increases, magnesium is oxidized. Hagagi Mg is a reactant at anode. Corresponding product Mg is converted to Mg plus 2, that is Mg2 plus, and of course concentration 0.13 molar. This is reactant at anode, product at anode. Then double vertical line haakbittu reactant at cathode, Ag plus is a reactant. Because Ag plus is reduced, reduction takes place at cathode. Ag plus is reduced to Ag, plus 1 becomes 0. Oxidation number decrease agutte. Hagagi the reduction, that reaction takes place at cathode, and of course you write reactant at cathode Ag plus, its concentration is 0.001 molar. Concentration of Ag plus baribeku, separated by Ag. This is solid. This is what we call it as cell representation for this cell reaction. Okay na? Iga nimage cell potential calculate madbeku. Yes, E of cell is equal to, yes, E naught of cell minus 298 kelvins ಆಗಿರೋದ್ರಿಂದ, that is 0.059 divided by n log to the base of molar concentration of product. ಇದರಲ್ಲಿ product ಏನು Mg2 plus. ಇದು ಸಿಲ್ವರ್ ಸಾಲಿಡ್ ಆಗಿರೋದ್ರಿಂದ its molar concentration 1 ಆಗುತ್ತೆ, divided by, yes, it is molar concentration of reactant ಯಾವ್ದಲ್ಲಿ, yes, it is silver ion. ಇದು ಕೂಡ reactant, but it solid state ಆಗಿರೋದ್ರಿಂದ, solid state ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ its active mass is 1, and of course Ag plus to the power 2 because coefficient of Ag plus 2 ಇದೆ. ಈಗ ಬನ್ನಿ, that is E of cell minus E naught of cell ಅವರ ಕೊಟ್ಟಿದ್ದಾರೆ, that is E naught of cell is given there, that is equal to ಎಷ್ಟಿದೆ 3.17 volts ಇದೆ. ಆಮೇಲೆ n value ಎಷ್ಟಾಗುತ್ತೆ ನೋಡಿ, number of electrons exchanged between cathode and anode. Mg is converted to Mg plus 2 by losing 2 electrons. Those 2 electrons will be taken up by 2 Ag plus. Hagagi number of electrons will be equal to, exchange will be equal to 2 there. N ಆಯ್ತು. ಈಗ concentration of Mg plus 2 ಬೇಕಲ್ವಾ, concentration of Mg plus 2 ಅಲ್ವಾ, that is 0. Yes, it is 13, yes, it is molar ಅಂತ ಬರಿಬಹುದು. ಇದನ್ನು ಬೇಕಾದ್ರೆ 13 into 10 to the power of minus 2 molar ಅಂತ ಬರ್ಕೋತೀನಿ for simplification purposes. ಈಗ ನೋಡಿ, that is molar concentration of Ag plus ಎಷ್ಟಿದೆ ಅಲ್ಲಿ ನೋಡಿ, molar concentration Ag plus is 0.0001 molar. ಇದನ್ನ 10 to the power minus 4 molar ಅಂತ ಬರ್ಕೋಬಹುದು. 0.001 molar is written as 10 to the power minus 4 molar ಅಂತ ಬರೀಬಹುದು. ಎಸ್, ಈ ವ್ಯಾಲ್ಯೂಸ್ ನಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ. ಈಗ E naught of cell ಎಷ್ಟಿದೆ 3.17 ಇದೆ, minus 0.059 divided by 2, ಯಾಕಂದ್ರೆ n is equal to 2. Yes, then log to the base of concentration of Mg plus 2 ಇದೆ ನೋಡಿ, that is 13 into 10 to the power of minus 2. 13 into 10 to the power minus 2 ಆಯ್ತು, divided by concentration of Ag plus ಇದೆ 10 to the power of minus 4, and of course it is whole square. ಈಗ ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ, that is E of cell is equal to 3.17 plus 0.059 by 2 ಎಷ್ಟಾಗುತ್ತೆ 0.0295 ಆಗುತ್ತೆ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ ಆಗಿ. ಎಸ್, ಇಲ್ಲಿ ಮೈನಸ್ ಇದೆ, ಹಾಗಾಗಿ ಇಲ್ಲೂ ಕೂಡ ಮೈನಸ್ ಬರೀರಿ. ಎಸ್, ಈಗ ನೋಡಿ ಇದನ್ನ 10 to the power minus 4 whole square ಏನಾಗುತ್ತೆ 10 to the power minus 8 ಆಗುತ್ತೆ. ನ್ಯೂಮರೇಟರ್ ಹೋದ್ರೆ ಏನಾಗುತ್ತೆ 10 to the power plus 8 ಆಗುತ್ತೆ. plus 8 minus 2 ಎಷ್ಟಾಗುತ್ತೆ 10 to the power 6 ಆಗುತ್ತೆ. that is log to the base of 13 into 10 to the power of 6 ಆಗುತ್ತೆ. ಈ 10 to the power minus 8 ನ್ಯೂಮರೇಟರ್ ಹೋಗುತ್ತೆ. 10 to the power plus 8 ಆಗುತ್ತೆ. 10 to the power plus 8 into 10 to the power minus 2 ಎಷ್ಟಾಗುತ್ತೆ 10 to the power 6 ಆಗುತ್ತೆ. that is therefore that is 3.17 minus 0.0295. This is yes it is log to the base of 13 plus log to the base of 10 to the power of 6. log AB ಏನಾಗುತ್ತೆ log A plus log B ಆ basis ಮೇಲೆ. that is 3.17 minus 0.0 yes it is 295 ಹೌದಾ. log to the base of 13 ಏನಾಗುತ್ತೆ ನೋಡಿ. that is log to the base of 13 ಎಷ್ಟಿದೆಯಪ್ಪ ಅಂದ್ರೆ that is 13 at 0 ಎಷ್ಟಿದೆ ಅಂದ್ರೆ 1139 ಇದೆ. ಎಸ್ ಹೌದಾ. ಇಲ್ಲಿ 2 ಡಿಜಿಟ್ಸ್ ಇರೋದ್ರಿಂದ 1.11 log 13 is 1139 ಇದೆ. ಎಸ್ log 13 is 1139. 2 ಡಿಜಿಟ್ಸ್ ಇರೋದ್ರಿಂದ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ 1 ಆಗುತ್ತೆ. 90 size 1139 plus log to the base of 10 to the power 6 ಎಷ್ಟು 6 ಆಗುತ್ತೆ. ಹೌದಾ ಹೌದಾನೆ. ಹಾಗಾಗಿ this is 3.17 minus 0.0295 ಎಷ್ಟಾಗುತ್ತೆ 7.1139 ಆಗುತ್ತೆ. ಎಸ್ 6 plus 1.1139 ಆಗುತ್ತೆ 7.1139 ಆಗುತ್ತೆ. ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ that is the answer. yes is 0.0295 into 7.11 yes it is 39. it comes out to be yes 3.17 minus 0.2098 ಬರುತ್ತೆ. ಎಸ್ ಎರಡು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ 0.2098 ಬರುತ್ತೆ. that's equal to yes that is 2.9602 volts. this is the cell potential for the given cell reaction. ಆಗ್ಬೋದಲ್ಲ right. note it down. take a screenshot and just go for it. yes now let us see second problem here. calculate the equilibrium constant for the cell reaction. Cu plus 2Ag plus Q, Cu2 plus 2Ag. E node of cell is given 0.46 volts. On the basis of that, you are supposed to calculate what we call it as equilibrium constant. You know the expression for the equilibrium constant, that is E node of cell is equal to 0.059 divided by n log to the base 1 of Kc. This is the relationship between E node of cell and Kc. E node of cell is given and n value is known to you. Based on that, you are supposed to calculate Kc there. That is E node of cell is 0.46 volts. N for this reaction. Copper is converted to copper plus 2 by losing 2 electrons. Those 2 electrons will be taken up by 2 Ag plus ions. Therefore, number of electrons exchanged between cathode and anode is 2 there. N equals 2 ಆಯ್ತು and you are supposed to calculate Kc there, right? Substitute ಮಾಡಿ. that is 0.46 is equal to 0.059 divided by 2. yes log to the base 10 of Kc ಆಯ್ತು. therefore log to the base 10 of Kc equals cross multiply ಮಾಡಿ 2 into 0.46 divided by 0.0591. yes okay na. ಇದನ್ನ simplify ಮಾಡಿದ್ರೆ you are going to get look here 2 into 0.46 right divided by 0.059. that comes out to be yes it is 15.59 and of course 32. this is the answer. this is log to the base of Kc, that is 15.5932. therefore Kc is equal to what? antilog of 15.5932 ಆಗುತ್ತೆ. ಹೌದಾ. this is equal to antilog of 15 plus 0.5932. ಹೌದಾ. 15.5932 ಅನ್ನ 15 plus 0.5932 ಅಂತ ಬರ್ಕೋಬಹುದಾ. antilog of 15 is 10 to the power of 15. ಹೌದಾ. into antilog of yes ಎಷ್ಟಾಗುತ್ತೆ? that is 0.5932. yes. now antilog of 0.59 at 3 to ನೋಡಬೇಕು. now you are supposed to look at the antilogarithm 0.59 at 3 ನೋಡಬೇಕು. antilogarithm ಅಲ್ಲಿ 0.59 at 3 ಎಷ್ಟಿದೆಪ್ಪ ಅಂದ್ರೆ it is 3917 ಇದೆ, right? 3917 is antilog of 0.59 at 3. mean difference 2 ಹೋದ್ರೆ yes it is 0.59 mean difference 2 ಇದೆ. Mean difference ಅಲ್ಲೂ ಕೂಡ 2 ನೇ ಇದೆ. ಹಾಗಾಗಿ 2 add ಮಾಡಿದ್ರೆ it is 3919 ಆಗುತ್ತೆ. Yes, therefore that is 39, yes it is 19 into 10 to the power of 15. ಇಲ್ಲಿ 0 point ಇರೋದ್ರಿಂದ after one digit you are supposed to keep the, yes it is decimal point, 3.91 into 10 to the power of, yes it is 15. That is the answer. Yes, that is 3.919 into 10 to the power of 15. That is what we call it as equilibrium constant Kc for a given cell reaction. So ee tara ನೀವು calculate ಮಾಡಬೇಕು. Okay na? Yes. We'll take up third problem. Yes. Look at the third problem here. Standard cell potential for Daniell cell is 1.10 volts. Calculate standard Gibbs energy change for the reaction antide. Daniell cell ಅಲ್ಲಿ ನಡೆಯತಕ್ಕಂತ reaction ಅವರೇ ಕೊಟ್ಟಿದ್ದಾರೆ. ಅದರ ಬೇಸಿಸ್ ಮೇಲೆ you are supposed to calculate standard Gibbs energy change. You know the relationship between standard Gibbs energy change and of course the cell potential, that is NF E naught of cell. ಈ relationship ನಿಮಗೆ ಗೊತ್ತಿದೆ. E naught of cell given here, that is E naught of cell is equal to 1.10 volts and F is not due, that is 96,500 coulombs. N is 2 here because number of electrons lost by one atom of zinc is 2. Those 2 electrons will be taken up by copper 2 plus ions. Hagagi N is equal to 2 here. Substitute money, that is delta G naught is equal to minus 2 into 96,500 into 1.10 volts, and of course it will be in terms of joules there. Yes, right? 2 into 96,500 into 1.1. It comes out to be, yes it is 2,12,300. This is in terms of joules there. In terms of joules. Okay na? ನೀವೇನಾದರೂ kilojoules ಅಲ್ಲಿ ಬರಿಬೇಕು ಅಂದ್ರೆ you divide this by 1000. ಆಗೇನಾಗುತ್ತೆ 212.3 kilojoules. This is what we call it as delta G naught. Of course it is a negative value here. Okay na? Because for galvanic cells delta G naught is negative where free energy decreases. Right? This is what we call it as the calculation of delta G naught if E naught of cell is known to you. Right? Okay na? Note ಮಾಡ್ಕೊಳ್ಳಿ, screenshot ತಗೊಳ್ಳಿ. Okay na? Now we'll take up the fourth problem under, yes it is non-stick question. Agboda? We'll take up fourth problem, right? Now let us see problem number 4. Calculate the potential of hydrogen electrode in contact with solution whose pH is 10. For hydrogen electrode, I already gave the relationship between electrode potential and of course pH of a solution. So just remember, I gave it as, yes it is E of hydrogen electrode is equal to minus 0.59 into pH ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಆಲ್ರೆಡಿ ಒಂದು ಎಕ್ಸ್ಪ್ರೆಷನ್ ನಿಮಗೆ ಕೊಟ್ಟಿದ್ದೀನಿ. ಎಸ್, ಈಗ ನೋಡಿ pH 10 ಅಂತ ಕೊಟ್ಬಿಟ್ಟಿದ್ದಾರೆ, 0.059 into, yes it is 10, ಹಾಗೇನಾಗುತ್ತೆ 0.59 volts. This is what we call it as, yes it is electrode potential of hydrogen electrode which is in contact with solution whose pH is 10 there. This is what we call it as E of H2 is equal to minus 0.59 volts. ಇಷ್ಟನೇ ಆಗ್ಬೋದಾ? ನೋಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಈ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಆಲ್ರೆಡಿ ನಿಮಗೆ ಪ್ರೂವ್ ಮಾಡಿ ತೋರಿಸಿದ್ದೀನಿ. ಓಕೆನಾ? ಸೊ ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ ಕಾಲ್ electrode potential for hydrogen electrode for a solution with a pH value 10. Note it down. Yes. Look at the problem number 5. Calculate the EMF of the cell in which following reaction takes place. Reaction is given and you are supposed to calculate the E of cell or EMF, so cell potential, electromotive force, right? You know the formula, that is calculation of E of cell, that is E of cell is equal to, yes, E naught of cell minus at 298 Kelvin 0.059 divided by N log to the base of, yes, molar concentration of products, that is Ni2 plus. This is a product of the reaction. Ag is also product, but its molar concentration is 1 because it's a solid there. Divided by molar concentration of reactants adili Ag plus. Molar concentration of reactant ಏನು Ag plus to the power 2 because coefficient of Ag plus 2 ಇದೆ. Reactant nickel is also reactant, but its molar concentration of nickel is taken as 1 because it's a solid. Solids ಏನಿದೆ equation ಅಲ್ಲಿ ಅವುಗಳ molar concentration ನಾವು 1 ತಗೋಬೇಕು. Molar concentration of product divided by molar concentration of reactant. Product is nickel ion, its concentration divided by reactant is Ag plus its concentration. Power 2 because coefficient of Ag plus is 2 here. Your E naught of cell is given. E naught of cell is given. That is 1.05 volts. How the N is, this can be decided on the basis of equation. One atom of nickel loses 2 electrons. By losing 2 electrons, it becomes Ni plus 2. And those 2 electrons will be taken up by Ag plus. Therefore, number of electrons exchanged between cathode and anode is 2. N value gottaitu. Amele, as far as concentration of nickel plus 2 is concerned, look here. Concentration of nickel plus 2 is yes, it is 0.16 molar. That can be written as 0, that is 16 into 10 to the power minus 2 molar anta barkobodu. Howda? 0.16 molar can be written as 16 into 10 to the power minus 2 molar anta baribodu. Yes. Again, concentration of Ag plus ideyala, that is 0.002 molar, that is 2 into 10 to the power minus 3 molar anta baribodu. Evaluation alli substitute madre, substitute madi 1.05 minus 0.0591 and of course divided by 2. Log to the base 10 of N is equal to 2 ide. Nickel is nodi, that is 16 into 10 to the power minus 2. Yes, divided by, yes, 16 into 10 to the power minus 2. Yes, divided by 2 into 10 to the power of minus 3 whole square because Ag plus to the power 2 ide. That is 1.05 minus 0.0295 log to the base 10 of nodi 16 by 4 estaಗುತ್ತೆ 4 ಆಗುತ್ತೆ into 16 by 4 estaಗುತ್ತೆ 4 ಆಗುತ್ತೆ 10 over minus 2 into 10 over minus 6 ಆದ್ರೆ ಎಷ್ಟಾಗುತ್ತೆ ನೋಡಿ, that is 10 to the power of, yes it is minus 6 ಮೇಲೆ ಹೋದ್ರೆ 4 ಆಗುತ್ತೆ. Yes, and that's equal to 1.05 minus 0.0295 log AB apply ಮಾಡಿದ್ರೆ log to the base 10 of 4 plus log to the base 10 of 10 to the power of 4 ಆಗುತ್ತೆ. ಹೌದಾ? log AB is equal to log A plus log B ಆಗುತ್ತೆ. Yes, that is 1.05 minus 0.0295 log to the base 10 of 4 is 0.6021. ನೋಡಿ ಇವಾಗ ನಿಮ್ಮ logarithms ಅಲ್ಲಿ at 40 ನೋಡಿ 40 at 0 is to 6021 ಬರುತ್ತೆ. 1 digit ಇರೋದ್ರಿಂದ 0.6021 plus and of course floor. ಹೌದಾ? Now it is 1.05 minus 0.0295 into 4.6021 multiply ಮಾಡಿದ್ರೆ that is 0.0295 into 4. Yes, it is 6021 multiply ಮಾಡಿದ್ರೆ it is, yes it is 0.13, yes it is 57 ಬರುತ್ತೆ. Subtract ಮಾಡಿ, yes it is 1 minus 1.05 minus 0.1357, that is it comes out to be, yes it is, that is 0.91 and of course 42. This is what we call it as cell potential E of cell. Yes, this is what we call it as cell potential E of cell. Agboodala? Look at the problem number 6 here. The cell in which following reaction takes place: 2 Fe3 plus ions plus 2 I minus B gives 2 Fe2 plus I2. I2 is in solid state. E naught of cell is 0.236 volts at 298 kelvins. Calculate delta G naught, standard free energy change and equilibrium constant Kc for the cell reaction ಅಂತ ಇದೆ. ಈಗ ನೋಡಿ given data ಬರ್ಕೊಳ್ಳಿ, that is E naught of cell is equal to 0.236 volts. ಇದಂತೂ ಕ್ಲಿಯರ್ ಇದೆ. N value ಈ reaction ಗೆ ನೋಡಿ Fe3 plus is converted to Fe2 plus by gaining 1 electron. 2 Fe3 plus becomes 2 Fe2 by gaining 2 electrons. Those 2 electrons will be given by 2 I minus. Therefore, N is equal to 2 here. And of course, delta G naught is equal to minus N of E naught of cell. ಇದು ನಿಮಗೆ ಗೊತ್ತಿರೋ ವಿಚಾರ. Substitute ಮಾಡಿ minus 2 into 96,500 into, yes it is 0.236 and of course it is minus ಅಲ್ಲಿ ಬರುತ್ತೆ in terms of joules. Calculate ಮಾಡಿ ಎಷ್ಟಾಗುತ್ತೆ ನೋಡೋಣ. Yes, 2 into 96,500 into 0.236, it comes out to be, yes it is 4,55,048. Or you can say that is, sorry, that is 45,548 joules, or you can say it will be, yes it is minus 45.548, yes it is kilojoules. Sorry, so this is what we call a delta G naught here. Yes, And now we'll go for the Kc. You know this, as far as Kc is concerned, you know the formula, that is, yes, it is E naught of cell is equal to, yes, it is 0.059 divided by n log to the base 10 of Kc anta on the formula gottide, right? Substitute here, E naught of cell is, yes, it is, therefore, log to the base 10 of Kc equals, log to the base 10 of Kc is equal to n into E naught of cell divided by 0.059, that's equals, n is equal to gottide. E naught of cell 0.236 gottide, divided by 0.059, 2 into 0.236 ಅದಲ್ವಾ, divided by 0.059, it comes out to be 8 there. Therefore, yes, it is log to the base 10 of Kc is equal to 8, then Kc is equal to anti-log of 8, of course, that's equal to 10 to the power of 8. So this is Kc value 10 to the power of 8. So this is what we call it as the expression for in calculation of Kc and delta G naught as far as problem number 6 is concerned, and note it down. We'll go to the next problem. Yes. Now let us see problem number 7 here. Calculate the delta G naught at 298 kelvins for this given cell reaction. Mg plus 2Al3 plus gives Mg plus 2 and 2Al here. This is a cell reaction given. And given data is E naught of magnesium. Standard electrode potential of magnesium is minus 2.37. Standard electrode potential of aluminum is minus 1.66 volts. And your F is 96,500 coulombs. And based on this, you are supposed to calculate, yes, it is delta G naught. Okay, so far, we were calculating delta G naught by knowing E naught of cell. Howda? Illivargu solve the problems E naught of cell direct kottidru, but illi E naught of cell kottilla. Instead, standard electrode potential of magnesium and aluminum in this particular cell reaction are given. And you can make use of those two standard electrode potentials to calculate standard cell potential. Look at this. Delta G naught is equal to minus N of E naught of cell. Howda? This is a formula. And here, N of this particular cell reaction, nodi. 1 mg loses 2 electrons to give mg plus 2. 3 mg will lose 6 electrons. Howda? 1 atom of magnesium loses 2 electrons and it becomes mg plus 2. 3 magnesium atoms are going to lose 6 electrons. 1 Al3 plus will become Al by gaining 3 electrons. 2 Al3 plus ions will gain 6 electrons. Totally, 3 magnesium atoms are going to lose 6 electrons. 2 Al3 plus ions are going to gain 6 electrons. Hagagi, number of electrons lost or gained will be equal to 6 here. And E naught of cell, yes, it is equal to E naught of cathode minus E naught of anode anta gottide nimage. E cell reaction alli cathode yadu nodi, that is aluminum, because Al3 plus ions undergo reduction. Atho hige helbodu. The standard electrode potential of aluminum is greater than standard electrode potential of magnesium. Hagagi, aluminum is one with the higher SRP is a cathode, one with the lower SRP is a anode. Adannu kuda neevu use madkobodu. Howda? Here magnesium is anode because magnesium is oxidized. Al3 plus ions will be reduced. Oxidation takes place at anode, reduction takes place at cathode. Adannu use madkobodu. Minus 1.66 minus of minus 2.37 alva. E naught of Al is to minus 1.66 minus of minus 2.37. Eshtagutte? It will be plus 2.37. Yes, 2.37 minus 1.66. It comes out to be, yes, it is 0.71 volts. 0.71 volts. That is what we call it as E naught of cell. Substitute ಮಾಡಿ ಅಷ್ಟನೇ ಈಗ. That is delta G naught is equal to minus 6 into 96,500 into 0.71, right? ಈಗ simplify ಮಾಡಿ. You are going to get the answer in joules there. Yes, 6 into 96,500 into, yes, it is 0.71. It comes out to be, yes, it is 4,11,000. Yes, it is 90. Yes, it is joules. Athwa, you can write it as minus, of course, minus 411.09 kilojoules kuda agbodu. Yes, this is what we call it as delta G naught here. Yes. So these are the yesterday some numericals on Nonstick equation. In the next video we'll see the remaining aspects of the chapter electrochemistry. It will be electrical conductance. Okay, now next discussion is on electrical conductance of electrolytic solutions. We'll see that in the next video. Thank you very much.